Hello guys, how are you? Welcome to Cosmic Essence Education. My name is Maitray, and in this video we'll be looking at the domain and range of all the 6 trigonometric functions. So let's get started. Okay guys, so let's discuss them one at a time. So y is equal to sin x. The domain of this function is the set of all real numbers, as the angle for which sin x is defined is all real numbers, all the angles from minus infinity to infinity. So y belongs to the set of real numbers. Range of sin x is between -1 and 1. So y belongs to the set of closed interval -1 and 1, which is also written as y is greater than or equal to -1 and less than or equal to 1. Then second, y is equal to cos x. The domain of this function is also the set of all real numbers, as this function is defined for all angles positive and negative from minus infinity to plus infinity. The range of this function is also closed interval -1 to 1, that is y is greater than or equal to -1 and less than or equal to 1. Now the third function, y is equal to tan x. Tan x is defined to be equal to sin x upon cos x. So tan x is defined for all real numbers except those values for which cos x is equal to 0. Yes, wherever cos x is equal to 0, tan x will not be defined. So we remove those angles. That's why the domain of tan x is the set of real numbers excluding all angles which for which cos x is 0, and that is the odd multiples of pi by 2. If we look at the unit circle and see where cos x is 0, we get cos x 0 at 90 degrees. The coordinate here is the x coordinate is 0. The angle here is pi by 2. And again, cos x is 0 when the angle here is 3 pi by 2. Again, it is 0 when angle is 5 pi by 2, then 7 pi by 2, and so on. So wherever the x coordinate is 0 in the unit circle, cos x is 0. That means that we will remove those values, and they are the odd multiples of pi by 2 from the set of real numbers to get the domain of tan x. Correct? Now the range of tan x. The range of tan x is the set of real numbers. Since tan x is defined as sin x upon cos x, its value can be anything from minus infinity to plus infinity. That's why all real values are possible. This is also written as y belongs to the set of open interval minus infinity to infinity. Okay, the fourth function, y is equal to cosec x. Now cosec x is defined to be equal to 1 upon sin x. So we remove those values of x or those angles from real numbers for which sin x is 0, right? So sin x is 0. Where is sin x is 0? Let's see on the coordinate plane. The y coordinate is 0 here and here on the unit circle. So the sin x is 0 whenever the angle is on the x-axis. So angle here is 0, pi, 2 pi, 3 pi, 4 pi, 5 pi, and so on. Negative angles can also be there, minus pi, minus 2 pi, minus 3 pi, minus 4 pi, and so on. So all integral multiples of pi are the angles where sin x is 0. So we will remove these angles from the set of real numbers to get the domain of cosec x. So y belongs to the set of real numbers excluding the set where x is equal to n pi, where n is an integer. This means we are removing those values for which sin x is 0 to get the domain of cosec x. Now the range of cosec x, okay, the range of cosec x is y is less than or equal to -1 or y is greater than or equal to 1. To see why this is, we know that cosec x is equal to 1 upon sin x. So now sin x is between -1 and 1, including both. So whenever sin x is close to 0, so from the when sin x is positive but very close to 0, cosec x will tend to plus infinity. When sin x is close to 0 but negative, cosec x will tend to minus infinity. Okay. Also, if sin x is between 0 and 1, cosec x will be greater than 1, right? And whenever sin x is between -1 and 0, cosec x will be less than -1. And when sin x is 1, cosec x is also 1. When sin x is -1, cosec x is -1. That's why cosec x is less than or equal to -1 or greater than or equal to 1. This is also written in set form as y belongs to the set of -infinity to -1 closed interval union closed interval 1 to infinity. This is the range of cosec x. Fifth function, sec x. Now sec x is the reciprocal of cos x. So wherever cos x is 0, sec x will not be defined. So we remove those angles for which we get cos x 0 to get the domain of sec x. So y belongs to the set of real numbers excluding those values for which cos x is 0, that is odd in multiples of pi by 2 where n is an integer. This gives us the domain of sec x, set of all real numbers excluding those where x is equal to 2n plus 1 pi by 2 where n is an integer. The range of sec x is same as the range of cosec x for the same reasons. So the range of sec x is y is less than or equal to -1 or y is greater than or equal to 1. That is, y belongs to the set of -infinity to -1 closed interval union closed interval 1 to infinity. Then the last function, y is equal to cot x. Now y is equal to cot x is defined, or cot x is defined as the reciprocal of tan x. So wherever tan x is that is y is equal to cot x is equal to 1 upon tan x, which is same as cos x upon sin x. So whenever sin x is equal to 0, cot x will not be defined. So we eliminate or remove those values for which sin x is 0 to get the domain. That's why y belongs to the set of real numbers excluding x such that x is equal to n pi where n is an integer. This means we are removing those values from the set of real numbers for which sin x is 0. Now the range of cot x, since cot x is the reciprocal of tan x, its value also ranges from -infinity to infinity. So the range of cot x is the set of real numbers, that is y belongs to the set of -infinity to infinity. So we covered the domain and range of trigonometric functions in this video. I hope you liked the video. Hit the like button if you did, and subscribe to our channel for more great videos like these. Thank you.